All right then. So let us try to go through question number 2. So remember, question number 2, it's basically based on the topic, which is called atomic combination. So when we talk about the atomic combination, we are most definitely talking about the periodic atoms combining together to form different types of molecules or to form different types of complex compound molecules. So now, when we solve these questions, most definitely we're going to dwell on the basics, some of the basics that are regarded to this topic. So question number 2, it reads as follows. It says to us, ammonia is an important gas used in the preparation of fertilizers. An ammonia molecule is formed when electrons are shared. This is very important. An ammonia molecule is formed when the electrons are shared. So now, before we can even go further based on this statement, I want us to talk about types of bonds. We have learned that there are different types of bonds. We have the covalent bond, we have the metallic bond, and we have an ionic bond. We know that when the electrons are shared between two atoms or between more than two atoms, we have a type of a bond there. Say, for instance, we have the electrons between atom A and atom B. Atom A and atom B together, they are combined to form what you call a compound. Now, these two atoms, when they combine together, they share these 4 number of electrons between them. For a fact that these two atoms, they share electrons, what type of a bond are we talking about here? Again, it depends on type of atoms are bonding here, the type of a bond. So if atom A, it's a non-metal, and atom B, it's a non-metal. Therefore, these electrons will be shared. And therefore, a type of a bond that exists between these two atoms, we're going to call it a covalent bond. Okay? So meaning this statement, it is very powerful. It has a meaning behind it. So they are telling us that we have what you call an ammonia, which is given by this formula, chemical formula, which is NH3. So NH3, it is a molecule of ammonia made up of combination of atoms. And I want you to bear in mind that these atoms are all non-metals. Nitrogen and hydrogen are all non-metals. So when these atoms combine together, they share the electrons between them. So now you can tell a type of a bond that exists in ammonia molecule, it is referred to a covalent bond. So let us continue reading the statement. An ammonia molecule is formed when electrons are shared between 3 hydrogen atoms and a nitrogen atom. So we have 3 hydrogen atoms and 1 nitrogen atom. So these 3 hydrogen atoms, most definitely they're gonna bond to nitrogen atom. They're gonna surround a nitrogen atom. So if I have my central atom to be my nitrogen atom, that means I'm gonna have 3 hydrogen atoms surrounding the nitrogen atom. So a bond that's gonna exist at this position, and a bond that's gonna exist at this position, and the bond that's gonna exist at this position, it's between the non-metals. It's between the non-metals. Therefore, this type of a bond within this molecule of ammonia, we're gonna call it a covalent bond. That's very important. And do not forget here, we are talking about the atomic combination. So now let us try to solve the questions. Most definitely, we start with question number 2.1. Now 2.1, it says to us, name the type of chemical bond formed between a hydrogen and a nitrogen atom. So basically, a type of a bond that exists between a hydrogen atom and a nitrogen atom. This type of bond over here, we're gonna call it, answer will be covalent bond. Remember, it is a bond that occurs between a nonmetal atom and a nonmetal atom, whereby there is a sharing of electrons between the two nonmetal atoms. Therefore, the correct answer for 1 mark will be a covalent bond. Now 2.2, it says to us, how many valence electrons does a nitrogen atom have, for 2 marks? Now here's the thing, which I believe a lot of learners, they're confused. So we have what you call the valence electrons, and then we have what you call the valency. Okay, we have what you call the valency. So when you talk about the valence electrons, what type or what electrons are we talking about? When you go on your periodic table, now each atom, it has its group, right? So a periodic table, it's something that looks like this. I didn't insert it here, but it's fine. I'll just try to have a picture of a periodic table. So a periodic table, it's something that looks like this, right? So now here we have the groups of our atoms. Here we have the groups of our atoms and so forth. Now this is the number of atoms that you find in this group. We're gonna call them the group 1, group 2, group 3, group 4, group 5, until group number 8. The last group is group number 8, which is the noble gases. Now, any atom that you get in any group, when you talk about the valence electrons of that atom, it is represented by their group number. For an example, let's talk about hydrogen. The hydrogen that we get in group 1, which is the first atom in our periodic table. For a fact that hydrogen is in group 1, that means the valence of hydrogen is going to be 1. Now in group 2, we have beryllium. Now, for a fact that beryllium, it is in group 2, therefore the valence for beryllium, it's going to be 2, okay? Even the atom that falls under beryllium, for a fact that they are in group 2, that means all of these atoms, they have valence of 2. Even same applies to group 7. These are inert gases. We say they are stable, so they do not have valence electrons because these group 8 elements, they are inert. That means they cannot react with other atoms. They are already stable. So that means here we have what you call the fluorine. Now, the valence electron for fluorine, it's how much? Yes, it is 7. The valence electron of fluorine, it's going to be 7 because it is in group 7. Now, I want us to talk about the valency. So now, what is valency? Valency, it depends on type of atoms that we're talking about. So when you talk about valency, we can talk about the cat ions. When you talk about the valency, we can also talk about N ions. Now, the cat ions are positively charged ions, and then N ions are negatively charged ions. So now when you talk about the valency for cat ions, we say valency for cat ions are the are the number of electrons that needs to be distributed or needs to be donated by an atom to be stable. But when you talk about the valency for an ion, we are talking about the number of electrons that an ion needs to accept in order for it to be stable. Now, I'm going to make an example based on valency. Okay, I know we understand the valence based on. So now let's talk about the chlorine. Okay, the chlorine. Now the valence for chlorine, we said it's 7. Okay, because the outer energy level of chlorine, it is composed of 7 electrons, and therefore these 7 electrons, they cause chlorine not to be stable. Now, according to octet rule, we know that the outer energy level of each electron must attain 8 number of electrons. So meaning this valence electron is an indication that shows that an outer energy level of chlorine, it is composed of 7 number of electrons. Now let's talk about valency of chlorine. Now chlorine, it is a what? It is a non-metal. So we said it is an ion again. We say that the nonmetals, they accept or they gain the electrons. So I said to you, for a chlorine to be stable, it's supposed to obey an octet rule, whereby the outer energy level of the chlorine is supposed to be surrounded by 8 electrons. So that means chlorine, since when it accepts the electrons, chlorine is supposed to accept how many number of electrons? Chlorine is supposed to accept only 1 electron, so that this 7 can be changed to 8. Therefore, we can say now chlorine, it is stable due to its outer energy level. Its outer energy level now has 8 number of electrons. So that means 7, it is the valence of chlorine, and then 1, it is a valency of chlorine. So on your periodic table, this is what I would like to, this is how I used to advise my learners. So here on chlorine, you just gonna write -1 to show that these are ions, they are negatively charged, they accept the electrons. And then group number 6, you're just gonna write -2, and then this following group you write -6. And then here on group number 1, it's +1. Why? Now let's take, I'll say what? I'll take sodium, okay? Sodium, we said it is in group 1. Therefore, what is the valence for sodium? It's gonna be 1, the valence for sodium, okay? Meaning the outer energy level of sodium, it has only 1 electron. Now, what is valency of sodium? The valency of sodium also is gonna be 1, okay? Now, here's the thing. I said to you, sodium, it is a metal, okay? It is a cation. So that means sodium, it's a type of an atom that donates the electron. The metals, they donate, the non-metals, they accept. So for a sodium to be stable, this valence electron, it makes sodium not to be stable. But now for the fact that sodium, it is a metal, that means this valence electron needs to be donated. And therefore now, how many number of electrons now are going to be there at the outer energy level of sodium? Therefore, the outer energy level of sodium that initially had only 1 electron will be eliminated. And therefore, the outer energy level of sodium now will be filled with 8 electrons, meaning sodium will be obeying an octet rule. So that means sodium is supposed to donate only 1 electron for it to be stable. And as sodium donates 1 electron, it's gonna have how many number of electrons? 10 electrons. And therefore, this 10 electron will correspond with what you see on the noble gases there as neon. Okay? All right. So these are just basics that you need to familiarize yourself with. So here they say to us, how many valence electrons does a nitrogen atom have? So that means a nitrogen atom, it is in which group? That's what you need to ask yourself. It is in group. We go to your periodic table and trace where is nitrogen. It is in group 5, okay? From the periodic table, it is in group 5. So that means it has 5 valence electron, our nitrogen atom, okay? It's in group 5. Now 2.3, it says to us, write down a Lewis structure for the ammonia molecule, okay? So Lewis structure for ammonia molecule, remember, this is our ammonia molecule, so we need to write the Lewis structure. So when we draw a Lewis structure, we represent a Lewis structure with dots and crosses per se. So now, in this case, we use the valence electrons to draw Lewis structure. So in order for us to draw a Lewis structure, let's start here. Nitrogen, it has how many number of valence electrons? We said it's 5, right? And then hydrogen, it has how many number of valence electrons? Hydrogen, it is in group 1. That means it has only 1 valence electron. But do not forget that we have 3 hydrogen atoms that has 1 valence electron. So that means in this case, for a fact that nitrogen, it has 5 valence electron. In this case, our nitrogen will be a central atom. So we're gonna draw our nitrogen as a central atom, and then we're gonna represent nitrogen with its valence electrons, which is 5. So that means we're gonna have 1, 2, 3, 4, and 5. So these are 5 valence electrons for nitrogen atom. And therefore hydrogen, they're gonna be attached to nitrogen atom. So that means this side, we're not gonna introduce hydrogen because already hydrogen has 1 electron. So we can have 1, 2, 3 electrons. I mean, the number of electrons supposed to correspond. If hydrogen comes with 1 electron, that means nitrogen should give 1 electron as well. If hydrogen comes with 2, for an example, which is impossible, for hydrogen to come with 2 electrons, that means meaning energy that it gets supposed to receive energy that it propagates. So that means in this case, we have incomplete number of electrons. That means this 1 hydrogen atom will bring its 1 valence electron so that it can bond with nitrogen. Therefore, there is a sharing of 2 electrons between nitrogen and hydrogen. And do not forget, this type of bond we have already talked about. It is a covalent bond. Because it is a covalent bond, it occurs between the 2 nonmetals where there is a sharing of electrons. And therefore, we have eliminated this. And therefore, another hydrogen atom is going to come with its electron again, whereby it's going to share its electron with nitrogen, since well, nitrogen shares electron with hydrogen as well. And therefore, another valence electron for hydrogen, the third hydrogen, which is 1, it's going to come here, share its electron. And therefore, it is a Lewis structure of ammonia. But make sure that the central atom, it is surrounded by 8 electrons to show that nitrogen, it obeys an octet rule. So here we have 2, 4, 6, and 8. That means the central atom, which is nitrogen, it is surrounded by 8 electrons. It has obeyed the octet rule. So nitrogen, it's okay if it is not surrounded by 8 electrons because it doesn't obey an octet rule. Okay, therefore, it is the answer for number 2.3. Now let's move on to 2.4. Therefore, we move on to 2.4.1. Now, 2.4, it says to us, for the ammonia molecule, write down the following. For the ammonia molecule that we have discussed, write down the number of electron pairs surrounding the central atom, okay? So it's very important, I'm going back. It's very important for you to understand 2.3 so that when answering 2.4.1, you know how to answer it. Now, 2.4.1, remember, it wants us to determine, to write what? To write down the number of electron pairs. They didn't say number of electrons. They said electron pairs, okay? So that means how many number of electron pairs surrounding the central atom? So I said to you, our central atom, it is nitrogen. So how many pairs are surrounding nitrogen? 1, 2, 3, and 4. That means we have 4 pairs surrounding the central atom. So sometimes this question can come as, for the ammonia molecule, write down the number of electrons surrounding the central atom. So they're gonna be 8. We're gonna say 1, 2, 3, 4, 5, 6, 7, and 8. So be careful when answering questions like this because you need to understand what is being asked to you. So here they want us to determine number of pairs, not number of electrons, meaning we have 4 pairs of electrons surrounding the central atom, which is nitrogen in this case. So that means you're just gonna write 4 pairs of electrons. That will be number 2.4.1. Now we move to 2.4.2. Now 2.4.2 says for the ammonia molecule, write down the number of atoms. Now it wants number of atoms surrounding the central atom. Again, we go back to our molecule, to our Lewis diagram. So the central atom in this case is nitrogen once more. Again, how many number of atoms surrounding nitrogen? It's 1, 2, 3, meaning 3 atoms, which is hydrogen atoms. They say the number, they didn't say write the name of atoms surrounding the central atom. They say the number. So that means it's gonna be 3 atoms. Okay, 3 atoms surrounding the central number. And therefore, we move to 2.4.3. 2.4.3 says to us, name used to describe the molecular shape. Okay, they want us to talk about the molecular shape of what? For the ammonia. For the ammonia molecule, write down the name used to describe the molecular shape. Now, before we can even talk about the shape of ammonia, let us try to draw, I will just say the atomic structure of the molecular structure of ammonia, not Lewis. It's gonna be hydrogen bonding to nitrogen, bonding to hydrogen, nitrogen again once more bonding to hydrogen, and then here we have pairs of electrons. Remember that. So remember this single line, it represents one pair of one pair of electrons, one pair of electron, one pair of electron. So this single line, that's what it represents. So now here they say to us, they want us to write the shape. It's fine. So now this is what you need to know when it comes to the shapes of our compounds. Now these electrons, we say the electrons, they highly hate spending time with one another because they are with the same charge. So that means they oppose each other. So now this is what is happening. The nitrogen, for a fact that it has the lone pairs, these are the lone pairs, okay? There are pairs of electrons that are not bonded to any atom. So these lone pairs, they're gonna pull the nitrogen atom upwards. Why? Because they need to repel with these electrons, as well as these electrons. So that means the nitrogen atom will be up there because of the lone pairs, and the hydrogen atoms will be down there because again the repulsion of the electrons, and therefore a shape that it is going to be formed, a 3D shape that's going to be formed over here of this molecule of ammonia. It's gonna be called what? It's gonna be called tetrahedral. Okay, it's gonna be called tetrahedral. This is the shape of ammonia, which is called tetrahedral. Right. So that means we move to the following questions. I hope that was clear. So now let us read this statement first before we can move to other questions. They say to us, ammonia dissolves readily in water to form ammonium ions. Okay. So the ammonium ions are denoted by this chemical formula. An ammonium ion is formed when an ammonia molecule shares a lone pair of electrons with a hydrogen ion. So the thing is, when water reacts with ammonia, that means ammonium ion will be formed. So that means water will give its hydrogen ion to ammonia, which is what we have just talked about. And therefore, as water gives its hydrogen to ammonia, ammonia will form a compound that we call, it will form an ion that we call an ammonium ion. So ammonium ion is denoted by this chemical formula, NH4 plus ion. Okay, this is ammonium ion. This is ammonia. Ammonia will react with water, whereby water will just only use its hydrogen ion. And this hydrogen ion, as it gets to ammonia, and therefore this will be formed, which is ammonium ion. So now remember, when we read this, they said, or they even told us that ammonia dissolve. I want this statement. Where is it? An ammonia ion is formed when ammonium molecule shares. This is very important. So ammonium ion, this thing gets to be formed when ammonia molecule share a lone pair of electrons with hydrogen ion with this. So this is gonna share. Remember, I said there are lone pairs of of ammonia on a base on top of nitrogen. So this lone pairs, hydrogen ion, it is a proton. Okay, so it doesn't have electrons at all. So for a hydrogen ion to be stable, in this case, hydrogen ion, it is unstable. So for it to be stable, it needs two number of electrons so that these two number of electrons can be balanced with number of protons found in this molecule, in this ion. So that means when these lone pairs, okay, let me write it once more again like this. So we have lone pairs, we have this, and then we also have that. So meaning these lone pairs, hydrogen ion will come here, and therefore there will be a bond between this nitrogen and this hydrogen. And therefore a bond will also be covalent bond. But this type of covalent bond is not a covalent bond that we know, because we know that in covalent bond, one atom will bring electron, and then another atom will bring an electron. Therefore, these electrons will be shared together. Therefore, it's a covalent bond. Now here, it is not a strict covalent bond that we know of. It is what you call a dative covalent bond or a coordinate covalent bond. So a dative covalent bond is what type of bond? It's a type of a bond whereby one atom will share its electrons with other atom. So meaning in this case, nitrogen, it is the only atom that has electrons. But in this case, these electrons will be shared amongst these two atoms. So for a fact that they are shared between the two nonmetals is a covalent bond. But for a fact that only nitrogen brought these shared electrons, not hydrogen. Hydrogen came with nothing. Nitrogen brought two electrons so that they can be shared between these two. So this is a covalent bond because there are shared electrons between the non-metal atoms, but at the same time, this nitrogen, it is the one that brought the electrons. Therefore, we call it a dative covalent bond. So that means ammonium ion, it is what we call the dative covalent bond. Now let us read the questions and answer them. So 2.5, it says to us, name the type of bond formed between ammonium molecule and the hydrogen ion. Ammonium molecule and hydrogen ion, it is called the dative covalent bond, like I said. Dative covalent bond. Or you can also call it coordinate covalent bond, okay? Now 2.6, it says to us, represent the formation, okay, let me use this other slide. So 2.6, it says to us, represent the formation of an ammonium ion with the aid of Lewis structure. Okay, so that means here we're going to have to represent the ammonium ion using a Lewis structure. Let's get sorry about that. So what is happening here is that, remember, hydrogen ion, it doesn't have any electrons because it is an ion. And then remember, we can also call it a proton, okay? So it doesn't have any electrons around it. So hydrogen ion from water will react with ammonia, which is what we drew. I think it was on question number 2.3. So hydrogen ion will react with ammonia. So let me just represent it in this way. So remember we had 1, 2, 3, 4, and 5. Therefore, for hydrogen, it's 1. For this hydrogen, it's 1. For this hydrogen, it's going to be 1. Right? So that means here we are talking about addition of these two, hydrogen ion and ammonia, to form what? To form ammonium ion. So that means, remember, this hydrogen ion or this proton will be placed on these valence electrons, okay? On these not valence electrons, on these lone pair electrons. Therefore, this is what you're going to form. So we're going to have nitrogen as central atom. We have this. We have this. We have this. And on this side, remember, we have the lone pairs, but remember this hydrogen atom will be placed above this lone pairs. Therefore, this, we close it in a square bracket and therefore raise it to positive to show that ammonium ion, it has gained a proton whereby it shared these electrons together. Okay, so for 2.6, they wanted us to represent the formation of ammonium ion with the aid of Lewis structure. So this is how we're going to do it for 2.6 to get your complete 4 marks. Okay, that's how we solve 2.6. And therefore we move to 2.7, most definitely 2.7.1. Now let us read it together. 2.7, it says to us, for the ammonium ion, write down ammonium ion this. Write down the number of atoms surrounding the central atom. So this is the central atom. How many number of atoms? 1, 2, 3, 4. 4 atoms surrounding the central atom in this case, which is nitrogen. So we have 4 atoms surrounding the central atom. Okay. Therefore, 2.7.2, it says to us, for the ammonium ion, write down the name used to describe the molecular shape. Okay. So ammonium ion, now we do not have the lone pairs, but one thing for sure that we know is that these electrons, they don't like spending time close to one another. So therefore, they're going to have to repel. So as they repel, they're going to form a molecule. They're going to form a molecule that is called tetrahedral. Okay? Tetrahedral. Now, this is what I'm going to do based on the molecular shapes of our atoms. Okay? Also going to post a video based on the molecular shapes so that you can see how do we see the molecular shapes of different atoms. Okay. All right. So this will be 2.7.2. Therefore, we move to the last question, which is 2.8. Now, 2.8, it says to us, which, it starts here. The nitrogen atom can also bond with itself to form the nitrogen molecule. It's true. Nitrogen atom can bond to nitrogen atom to form molecule, which is nitrogen gas. We know that this is how nitrogen gas is formed. It's a diatomic gas. Okay. So that means nitrogen to nitrogen forms N2. That's true. The nitrogen atom can also bond with itself to form the nitrogen molecule. Now 2.8 says to us, which one of the following bonds will be the strongest? They are asking. We have bond number 1 at first. Bond number 1, it's bond between nitrogen atom and hydrogen atom. This will be bond number 1. Or this will be the strongest one we are asking, right? It's either number 1 or number 2 will have the strongest bond. Or bond between a nitrogen atom and most definitely a nitrogen atom. Therefore, write only one in Roman figure or 2. Give a reason for the answer between these two options, which one is correct. So now this is what is happening. Remember, the valence electron, so we're gonna do it in so that you can see it or you can understand it much more better in Lewis structure, okay? So the thing is, we have already talked about a bond between, or we have already seen a bond between nitrogen and hydrogen that it is denoted by 2 electrons. And I just said to you, 2 electrons represent only one, or single bond, represent single bond, okay? So that means between nitrogen and hydrogen, we have a single bond, whereby single bond, it is denoted by 2 electrons or one pair of electrons. Now, when nitrogen bonds with nitrogen, let me show you something, okay? So the valence electron for nitrogen, it's 5, right? So it's gonna be 1, 2, 3, 4, and 5. So for this nitrogen, once more again, it's gonna be 1, 2, 3, 4. Okay, I'll write 5 over here and 5. Now, this is what is happening. Remember, when these two atoms bond together to form a stable compound, these two atoms must obey an octet rule whereby these atoms supposed to be surrounded by 8 electrons. Now, let's confirm that is this nitrogen surrounded by 8 electrons? By 8 electrons. Sorry about that. So this nitrogen is surrounded by 1, 2, 3, 4, 5, 6 electrons. That means this nitrogen atom is also surrounded by 6 electrons. That means this is not the correct way to draw a Lewis structure. Then what are we going to do? We're going to move 1 electron to the bond side and the other electron to the bond side. So that means we have N there. Remember here we have 2 electrons. So here we have 1 electron. So I'm going to move this electron over here so that they can be 2 of them. Okay, and therefore same applies to this one. I'm just gonna remain with this over here. I'm gonna remember I still have this one over the bond side, and then I move this one here over here. Now, and then I have extra one over here. It's supposed to be 5 for this one. So let's see. Does this obey an octet rule? So that means this nitrogen is supposed to be surrounded by 8 electrons. So we have 4, 6, 7. So that means this nitrogen is surrounded by 1, 2, 3, 4, 5, 6, 7. It's surrounded by 7 electrons. Once more again, same applies to this nitrogen. It is also surrounded by 7 electrons. It doesn't obey an octet rule. Lastly, let's move this electron to C. So that means we have nitrogen. We move this electron to the bond side. So remember, these are already there. So we have 1, 2, 3. And therefore, I'm just going to remain with these 2, which is the valence electrons. Remember, supposed to be 5. And therefore, I'm going to do the very same thing here. I'm going to move this electron over here. So I'm going to have 1, 2, 3, and then nitrogen. And then these 2, they're just going to be over here. Now, let me see if this now obeys an octet rule. So now I have this nitrogen, it's surrounded by how many number of electrons? Let's see. We have 1, 2, 3, 4, 5, 6, 7, it's 1, 2, 3, 4, 5, 6, 7, 8. So this, it is surrounded by 8 electrons. Let's confirm for this one and check if it's surrounded by 8 electrons. It's 1, 2, 3, 4, 5, 6, 7, 8. Even this one, it is surrounded by 8 electrons. Therefore, this is the correct way to draw a Lewis structure for nitrogen to nitrogen. So now remember, 2 electrons, they represent one bond, okay? So 2 electrons, they represent one bond. 4 electrons, they represent two bond, as double bond. And then 6 electrons, they represent triple bond. So that means a bond between nitrogen and nitrogen, it's going to be a triple bond, right? A bond between nitrogen and hydrogen is going to be a single bond. Now, the question here, it says to us, which of the following bonds will be the strongest? Is it gonna be 1, which is nitrogen and hydrogen, or is it gonna be 2, which is nitrogen and nitrogen? So the correct answer here to answer this 2.8, let me try to answer it over here. So 2.8, the correct answer, it's gonna be 2, right? But then give a reason why do we say it's 2. It's because triple bond is much stronger than single bond, okay? Triple bond is stronger than a single bond that we find on nitrogen and hydrogen. And I hope that was making sense. So don't forget to comment, subscribe, and share with some of your friends, okay? I hope that was helpful.